Let's take a look at finishing the Hardys we started the other day. They're all forged, and they're pretty rough right now, or at least most of them are. I've actually ground a couple of them, but I want to cover the grinding on at least one of them. When you grind these, the first issue is just to make a functional tool. Get rid of any sharp spots, any burrs that might propagate a stress crack or might cut you or be uncomfortable. Shape the edge so it's a good functional edge. And after that, anything else you're doing is purely aesthetic. If you want to take the whole tool to a mirror polish, that's up to you. It's not going to work any better. As long as it's got a good sharp cutting edge and it's not ragged and jagged or misshapen, it's going to work. So if you want to polish it, great. I'll probably clean up the profile a little bit just so it's a tool that I'm happier with the way it looks, but I'm not too worried about getting all the hammer marks out or making it sparkle and shine. So these are the Hardys we made the other day when we were talking about it. I'm not going to worry. Let's see if I can get those back up in the camera view there. I'm not going to worry about this one. I'm not happy enough with the way it came out. It would be a 100% functional tool for what it is. And if this is the best you can do, make it, harden it, temper, sharpen, use it, and eventually work up to something a little bit nicer. But since I have other Hardys, and since I don't actually need any of these, I'm going to straighten this piece of coil spring back out, and that'll make a nice couple of drifts or punches or chisels or something like that, and I'll get better use out of that material. So I'm not going to worry about grinding it. But these are the other two we forged. I've already ground the straight-sided one, and I did clean it up to a 220 grit finish just to make it smooth and make it look good. But you don't really have to go that far if you don't want to. The final sharpening will be done after they're hardened and tempered. And this is the one out of the jackhammer bit. This is the one we're going to go ahead and show you how to grind. We'll try to take some of the telltale signs that we had to twist it out just so it looks a little bit better, clean up this end, and give it a better profile here. This last one is one I made out of a heavier piece of stock. This is made out of 1¼ by 2 inch material, and it actually fits my anvil and isn't a bad size Hardy for that big anvil. So it's one we will cover the way I did this in a future video. You should always secure your piece in a vise when you're grinding. We're going to use the angle grinder that we talked about the other day. So I think it's a real handy way to do this. You should also, ideally when you're grinding, wear respiratory protection. It's worth the effort. And hearing protection. So all I've done initially is just clean up the end where it was kind of puckered over from forging, and that's all that really needs. And now we're going to go on to this portion of it. I think it'll be easier if you can hold it kind of at an angle in the vise. It's easier to see what you're doing, and easier angle to get the grinder into. That just cleans up the forging and makes something that looks about right. I like my Hardees fairly straight on the top. Some people like a big arch, and that's okay, but I don't like the corners real sharp, so I knock the corners back off. And I'll round those up a little bit in the next step. That's really all it needs initially, but this is a real coarse hard wheel on the grinder, and I think we can do a lot better with a not much prettier surface if we go to a finer abrasive. I've got a hard disc in the grinder right now, and it's really coarse, and too many coarse scratch marks can leave a place for stress to build up when hardening and tempering. So you really want to take out most of those. And these sandpaper flap discs, and this one's threaded, so you don't need the wrench and the nut. They're pretty easy to change, and you can get these at all sorts of different grits. Always unplug your grinder when you're changing the wheels. And of course, if you don't have a powered grinder, you can do all of this on a pedal or hand cranked sandstone wheel, and you can do it all with a file. File's just going to take a little bit more elbow grease. It will also encourage you to do a better job forging so you don't have to do so much filing. So now we're ready to harden and temper our Hardie tool. The subject of hardening and tempering comes up quite often. I've talked about this in several previous videos, and I will try to put a link right up in this corner over here to one that discusses it in some detail. And in that video on making punches and punches and drifts for hammer making, I talk about doing test hardening and some ways to try to figure out what you should do. And I encourage you to watch that video. I also encourage you to read the chapter on metallurgy in the new Edge of the Anvil if you have access to that book. It's probably one of the best simple explanations of hardening and tempering there is. But we'll cover it again briefly today because it does come up, and apparently people don't go back and watch videos that are 6 months old very often, so I think this topic we will cover quite frequently, and maybe I'll get better at explaining it. So there's essentially 4 parts to heat treatment. The first would be to normalize a piece of steel, and that just means bring it up to heat and let it air cool. Now that works for water hardening steels. It doesn't work for air hardening steels because you're hardening them by letting it cool in air, and for oil hardening steels it's kind of iffy. So a better step, and that leaves the steel even more stress-free than normalizing, is annealing. And that's, as a blacksmith, we tend to bury it in a bucket of ashes or some vermiculite, and that cools it very slowly, and we consider that that is annealing. Industry standards would not agree with us. They have formulas for every steel: bring it up to this temperature, cool it this many degrees per hour till it gets to a certain temperature. And it can be a 24-hour process of controlled heat reduction after it gets to that critical temperature. And in the blacksmith shop, we're just not that picky, and we don't have the ability to worry about a lot of that stuff. So we're generally pretty satisfied with annealing by letting it slow cool and vermiculite. It's not the absolute best, but if you stick with fairly basic, fairly simple steels, it's more than sufficient. So after it's been annealed and or normalized, or maybe you've done both for some reason. Some people will run it through an annealing cycle and then several normalizing cycles. And that's popular with knife makers, but we're not talking knives here, we're talking chisels. The next step, that's when you do all your grinding. You're not going to hurt the heat treat because it hasn't been hardened and tempered. So you can grind it, you don't have to worry if it gets hot. Get it to shape. Then it's time to harden and temper. Hardening will make this as hard as you can get it. That you bring it up to the appropriate temperature, and we'll discuss that in a bit. And then you quench it in the appropriate medium. And different steels have different mediums. Brine is the fastest cooling for tool steels. There's a thing out there called super quench that will actually harden to some degree mild steel, which doesn't harden under any other method. But you don't ever want to use super quench on tool steels. That's a guaranteed way to get a crack. The next fastest quench is water, then oil, and then air. And you need to know what the steel you have quenches in. If you buy new steel, you'll know. If you buy W1 steel, that's water hardening steel, you know it quenches in water. And probably if you buy new steel, it will come with a little guide. Frequently you get a little card with it, or it's printed on the package, depending on where you buy it, what it takes, or the manufacturer will have something on their website that tells you what the temperatures are and the hardening medium and what the tempering requirements are. So that's the ideal. But we're using junkyard steel. So I've got a piece of jackhammer bit. I have no idea initially what that is, so I have to kind of test it out. So I don't just go quench this in brine and hope for the best, because it may just crack and fall apart, and I may pull out just a stub of it, and the rest of it will be at the bottom of my bucket because I shouldn't have quenched it in brine or water. Although that might be the appropriate, but we don't know when we get it. So we have to do test procedures. And in that previous video that I mentioned, I discuss how to do those test procedures. And I encourage you to do that with any unknown steel. Essentially, you will take a scrap, because you don't want to ruin your tool accidentally, and initially bring it up to temperature and let it air cool. Did it get hard? Check it with a file. If you file it and it files, it's not hard. Heat it up again. Quench it in oil. Did it get hard? Yeah, maybe sort of. You want it a little harder? Do it again. Quench it in water. If it's hard as glass after the water quench, that might be a little harsh, but you might be able to temper it out, and you're going to have to play with this stuff a little bit. If you draw the material out into a thin bar and try to break it after hardening it, that'll tell you a lot. If you can't break it and it springs back and doesn't bend, that's probably a pretty good hardness for a lot of stuff. But you have to go through some tests with junkyard steels if you don't have a good idea what they are. Luckily, a lot of this stuff we know. We know coil springs, leaf springs from older cars are generally 5160, and you can look up 5160 in one of the charts and see how that hardens. So if we were doing this Hardy that was out of coil spring, that's probably pretty close. Now, new springs aren't necessarily 5160. Every auto manufacturer now has their own specific proprietary steel formula, and they're not going to tell you what it is, so it's a good idea to do the test procedures. Sucker rod is generally 4140 or 4130, so that's pretty easy to look up and find the data on that. After using these jackhammer bits for years, and I've made little hammers out of them, I've made punches and drifts and Hardy tools, and who knows what tools I've made out of them. I have finally decided they are probably S2, which is a shock resisting tool steel, and there are lots of different flavors of shock resisting tool steels out there. S7 is a air hardening steel, and I use that for small punches quite regularly. But S2 is actually a harden in water or harden in brine steel. So this we're going to harden in water, and that makes our life really nice and easy for this. The one out of sucker rod that we did, the 4140 or 4130 hardens in oil, so we're going to quench that one in oil. And we'll go ahead and harden and temper both of these, and we'll talk about that. Where do you find all this information out? Once you think you know what steel you have, or you bought new steel and you know exactly what you have, you got to be able to look it up. There are various books out there. Now this little one called Metallurgy and Heat Treatment talks a lot about theory, but it doesn't have a lot about specific do this, do that kind of formulas, which I was really disappointed, because it's a nice, small, durable little book that looks like it'd be great in the shop. I haven't been real impressed with it. Heat Treatment, Selection, and Application of Tool Steels by Bryson. This has a lot of good information in it. You got to look through it to find it, but there are some charts on specific steels. It has S1, S5, S7. It doesn't have S2 in here, but it tells you some pretty specific hardening and tempering information in here, and you can find a lot of other information on just general practice, and it's a pretty good resource to have in your shop. It's still available new. You can get it on eBay, $40 or something like that. This chart I printed from McMaster Carr, and I can't find it on their website anymore. If it's still on there, I don't know where they've hidden it, but at one point it was easy to come by, and it has maybe a dozen different steels that they were selling at that time, and it does luckily have S2, which is what I'm treating this as. And S2, it says preheat to 1200 degrees, then bring it up to 1550 to 1650, so it tells you exactly, which we can't control perfectly in the forge, we have to go by color, and hold for 5 to 20 minutes, then quench in brine or water. So brine is salt water. So we'll quench in water. We don't need it rock hard, so if water's a little bit mellow or quench, we'll do that. And you could probably get by with quenching it in oil. It would not be very hard at all. But for a hardy, it would probably survive just fine because you're only using it on hot steel. And you're going to take all the temper out of it eventually with hot steel anyways. And then it has a tempering guide. We can bring it to a Rockwell of 56 if we temper it at 400 degrees, and that's probably about right. So that's a good resource to have right there. But I have another resource. There are apps for the smartphone. And unfortunately, the app I like the best doesn't seem to be out there anymore. It just kind of completely disappeared. But the one that I like, you also see I use my smartphone for a control here on the camera. It's called the Heat Treater's Guide. And it has, this is about what the icon for the app looks like when you go online to look for it. But you can search by type, and I've put in S2 here, and I can bring up S2. It'll tell me the chemical compositions, the specs, the characteristics, the applications, forging guidelines, and recommended heat treating practices, including all the temperatures for annealing, hardening, tempering. When we talked about annealing, it says heat to 1455, use lower limit for small sections, blah, blah, blah. Let's see. Hold for 1 hour for, let's see. Cool at a rate not to exceed 40 degrees per hour until it gets down to 950 degrees. So that's what it thinks you need to do to anneal. It doesn't say anything about vermiculite. The problem with this app is for tempering, it says to prevent cracking, temper within 10 minutes, temper at 345 to 795, and it doesn't tell you what tempering temperature results in what hardness. So it's very vague on the tempering information. And that's one of the things that I would really like to have is more specific tempering guidelines. But it's not a bad app, and every tool steel I've ever looked for is in there. Alloy steels, it's got information on 4140 and 5160 and W1 and O1, and pretty much everything is in there, and it's a pretty handy app. So we'll see if we can get the camera back here. By the way, this is why I picked this particular camera, so I can control it with my smartphone. In general, you want to bring things up to temperature very slowly, give them a soak at a lower temperature, and all those guidelines are in those references. In the forge, you have very little control. You can do your best guess by keeping the blower down or keeping the pressure on your gas forge down. The ideal is an electric heat treat oven, and that's what I tend to use. I finally got one a few years ago, and I love it. It's the way to go if you want exact, repeatable results. But blacksmiths have gotten by without electronic ovens for thousands of years, and their tools work, and we can still make tools that work today, especially for our own use. The reason I like the electric oven is because I make tools to sell, and adzes and axes and chisels and things like that. The customers expect pretty reliable results. I can get by with something that isn't perfect in the shop because I can always reheat treat it. So I'm going to put this on the fire, and I'm just going to let it sit there on the top of the fire to kind of preheat a little bit. And while it's doing that, I'm going to heat this bar up down in the fire, and I'll use that bar to preheat my water and my oil, because you don't want to quench in really cold quench medium. Your oil should be 200-300 degrees. Water should be warm to the touch when you go to quench. And since it was 20 degrees last night, this stuff needs to be warmed up. I keep my oil for heat treating, and it's a commercial quenching oil made for this purpose. It comes in a 5-gallon metal bucket. The 5-gallon metal bucket I have down here, a 10-gallon rag can with a spring-loaded lid. Oil burns. If this catches fire, I can let go of that lid and drop it off. This bar is just my preheat bar, so it's down there warming my oil up for me. And if it flares up and starts to burn, I can yank that bar out of there, let the lid close, and the fire will go out. Much safer. Never put your hardening tempering oil in a plastic bucket. People have burned their shops down because they've started a fire, melted the bucket, and then the burning oil goes everywhere. I actually have a little submersible heater in my water. It'll bring the water up to about 40 degrees, so I'll still take that steel bar and warm the water up a little bit more so it's warm to the touch. But at least this melts all the ice off of it. Now I've got all three of these tools in here preheating. Most tool steels recommend a soak around 1200 degrees, so that's kind of what I'm theoretically going for. 1200 is just below the incandescent range. In other words, if it's glowing red, you've probably got it too hot. So I just want to let these soak for a while. And again, I'm just doing this by intuition and by experience because I have no perfect temperature control. You could get an infrared thermometer and take a shot at this and see what you've got, see what your fire's at, but I don't think that's real accurate because the fire is going to be plenty hot, but the steel isn't yet. But I'm just going to let them sit on the fire and keep working, and I'm going to occasionally take my big bar out. It doesn't need to glow red hot either to preheat water and oil. It only needs to be about 500 or 600 degrees. Now I've let these sit and come up to temperature, and some of them are the hardy stems, because that's what I had in there, are just starting to glow, so they're a little higher than that 1200 degrees. And I'm going to put the one we're doing in water, the jackhammer bit that I presume is S2, and that's actually in the fire. The other two I've pulled out to the edges where they'll stay hot, but they won't come up in temperature any. And I'll do one at a time at this point. I don't know if you can see that or not. It's just starting to glow. It's kind of hard. Yeah, you can sort of see that. The camera's not very accurate on color, so don't use the camera color to tell. Now, a magnet will tell you something. So this is actually not sticking, so that's getting close. If a magnet sticks, it's too cold. Right about where a magnet ceases to stick is good for simple carbon steels. Unfortunately, these are not simple carbon steel, so it's not 100% accurate. These need to be a little bit hotter than that. So I'm going to bring this up just a little bit more. And turn that blower down quite a bit. And you really only need to harden the last inch or so, but you need a nice even heat. If there's a sharp transition between hot and cold, you're going to crack it. And the same thing goes for when you quench it. But you don't need to quench the hardy stem. You can let it cool off as slow as it possibly can, or at least not initially. Let it come way down in temperature. So this is still nowhere near magnetic. Most of the tool is too cool to harden, and that's just what I want. There's no reason to chance a crack. And I'm going to go in the water and move it up and down without going past the collar. So I'm not going any deeper than right about in here. And keep it moving up and down, figure 8, until all the glow around that collar disappears, and then we'll quench the whole thing. Fresh, clean water is your ideal water. This isn't, this old nasty slack tub isn't your perfect quenching medium. Okay, that's lost its incandescent color as far as I can tell anyways. And actually, if you put it down in the shadows under the forge, it still glows just a little bit. Slowly kind of work it back in. You don't want to hold it at one level because you can create what they call a water crack. For that reason, because you cooled off right at a set line, you want it to transition and go from maximum hardness to maximum softness over an area. Now I'm going to temper this in a toaster oven. If you've watched the other videos, you've seen me do that before. That way I can just put it in there, set it for an hour at 450, which should be a good temperature for this. And you want to do that pretty much right away. But before we go to that, I was off camera, so that doesn't cut, but the end of the hardy stem cuts nicely. So we're good and hard up in here, and we're not hard at all down in here. It slowly transitions from one to the other, and this is all that needs to be hard. So that's just perfect. I'm going to go put that in the toaster oven. You can certainly put these in the kitchen oven if they don't stink. I'd wash them off first. But I have had tools crack that I have set aside after hardening because I was going to take them in the house later and put them in the kitchen oven. So if you're going to do that, go in right away and do it. So now I'm going to heat up this one that I think is 4130 or 4140, the sucker rod. About the same dull red is what it's going to take, maybe just a hair hotter than what a magnet quits sticking. And then this one we're going to go to oil. So I'm going to check this with the magnet. I may have gotten this one a little bit too hot. That's a little more orange than I would like, but I'm going to go ahead and quench it anyways. We're going to quench it in the oil, same thing, up and down. Now I prefer to do this over by the door with the doors open and a fan blowing the oil smoke out. So I get my head way down so I'm below the level of the smoke. It's also why I would prefer to only work with water hardening steels. It just doesn't seem possible. Too many good steels are oil hardening. 4140 and 5160 in particular. But once the initial cooling is done, if I really needed to get away from the smoke, or if it flared up and started a fire, I could just set this on the bottom of the can and let the lid close, but the more you keep it moving, the more even your quench will be. So you wouldn't want to set it on the bottom initially. Then a commercial setting, industry just hardens the whole tool. That's an advantage of the way a blacksmith does it, is that we can get this variable hardness in there so that the body of the tool is tough and durable and the edge is sharp and will hold an edge well. So we'll do the same thing. That file just skates off of that. And bites very nicely into that end. So again, this part of the tool is fairly soft, and this part of the tool is good and hard and needs to be tempered. And I'm going to temper it at the same temperature that I'm doing the other one. 4140 actually can temper a little bit lower than that, but for a hardy I don't think that's going to hurt it. And after we've used this a few times with hot steel on it, it's going to temper way back anyways. We're going to let those temper in the toaster oven for an hour. That's a good time period. Check the charts and the tables and your other resources and see if they need something different than what I'm doing. Some steels like to be tempered at least twice, or they need to be tempered for 2 hours or whatever. But I'm pretty comfortable with this for these tools. So it's going to stay in there for an hour. I'm going to go have lunch, then we'll come back and we'll clean them up and sharpen them and see what we ended up with. After tempering, this should be just soft enough that you can sharpen it with a file if you need to. If it's still too hard to sharpen with a file, you probably need to temper it some more. Not longer, hotter. But if you don't want to do it with a file, you can go back to the grinder with a flap disc. Be careful, you can overheat the edge at this point. On the other hand, you're going to use this with hot material at the anvil, and that stuff's going to be 1500 degrees or hotter probably, so you're going to ruin the temper on the edge anyways. It's just part of the life of a hot work tool. You don't need to sharpen these razor sharp. These aren't woodworking tools. They're hot work tools for use at the anvil. And if they're razor sharp, you're just going to blunt the edge and roll it over the first time you use it. They just want to kind of feel generally crisp, I guess is a better word than sharp. But you don't want them dull either, because it's a lot more work. So it's worth taking the time to sharpen them from time to time. Hopefully you had a chance to find some of these materials that are a little easier to make a hardy out of. If you haven't, I will in a future video cover how to make a hardy starting from full-size stock, draw out the shank, create the shoulder, and then make the hardy. It's more work, but you do end up with a little bit nicer tool in my opinion. But there's nothing wrong with this one made out of the jackhammer bit or this one made out of the sucker rod. Both are excellent tools. These will both last you a lifetime of use, and there's no reason to shy away from them if you can get a tool a little bit quicker, a little easier, and if it's more to your mindset to make it that way. But if you want to make a full-size tool, we're going to do that at some point. This is the hardy made out of the sucker rod with the naturally existing swell. We just squared up the square section to make it a little bit longer and make sure it fits. And this is a single-sided hot cut. It will leave a straight edge on one end of your cut, so you can get a much cleaner edge for more finished work this way. And it's a little narrow. It's only about 1 inch, and that's a downside of the sucker rod, is it doesn't make a real large hardy. And this is the jackhammer bit. This is a much nicer tool, I think, of the two, and I really like the jackhammer bit for hardies if it fits your hardy hole. This will fit a 1-inch hardy hole. It's got a real nice stable collar to keep it in place. It's an 1 3/4 wide. It's got a nice slightly round edge on it, so it'll be easy to cut material on. And like I say, that's a Hardy you can have your entire blacksmithing career, and it's fairly simple to make. You just have to go out to your local rental store to try and find some jackhammer bits. That completes that little project. Quick look into making Hardys. That same technique can be used to make other tools that fit in the Hardy hole. You can make a butcher, which we'll do as a separate project as part of our wrought iron grill project, and we'll explain what a butcher is at that time. You can make swedges, you can make fullers, you can make little special purpose dies for rivet heading or whatever it is you need. Rose petals, leaf dies, lots of different things you can do with the same starting material and the same basic techniques. For our next project, though, I think we're going to get back to doing some tong making. These some of you have commented on. You saw them sitting on the workbench. These are tong blanks from Ken's Custom Iron. They're called quick tongs or rapid tongs, depending on which size. And I don't remember which size is which, but I'll explain that. I'll make sure I know when we do the video. But until then, get out to the shop, stay safe, wear your safety glasses. I hope you like this video. I'd love it if you'd hit that subscribe button. Share the videos with your friends. Go back, watch some of the older videos. A lot of the questions that folks ask have been answered in one of the previous videos. But if you haven't watched them and you want to ask a question in the comments, I will try to answer it. And if I can remember what video I may have talked about that subject, I'll give you a link to that video so you can find it a little bit easier. We'll see you later.